Hello everyone, my name is Jacob, and today we're going to be working on right triangle trigonometry, and we're going to be doing some examples on how to solve right triangle trigonometry. Before we start, we got to remember the six major trig functions, which are sine, cosine, and tangent, and their opposites, which are cosecant, secant, and cotangent respectively. Sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. Cosecant equals hypotenuse over opposite, secant equals hypotenuse over adjacent, and cotangent equals adjacent over opposite. So they're the reciprocals of the original. Okay, let's get started on our first problem. Alright. Okay. So before we begin, let's label this number 1, and let's read the problem. Suppose you have been assigned the job to measure the height of a farmer's silo. Climbing makes you dizzy, so you decide to do the whole job at ground level. From a point 47.3 meters from the base of the silo, you find that you must look up at an angle of 53 degrees to see the top of the silo. How high is the tower? So to begin most problems, I like to draw a visual, like a visual triangle, so I can see what I'm dealing with. So I'm going to draw my visual first right here. So I'm going to draw my basic right triangle, just like this. Just a basic right triangle with my right angle right in there. So then I'm going to, so it says the base of the silo, the farmer is 47.3 meters away from the base of the silo. So that'll be right here on the bottom, the 47.3 meters. And the angle where you can see the top of the silo is 53 degrees, which is called the angle of elevation. So we'll put that. So this is the top of the silo right here. So we can put 53 degrees right there. This is top of silo right there. So we're trying to find how high the silo is. So because of that, I'm going to put my X right there. That's where the height of the silo is. So to do this, we're going to have to use one of our trig functions, tangent, because we have an angle and then we have two sides, the opposite of that side and the adjacent of that side, which corresponds to tangent. So what we're going to do first is we're going to write tangent of 53 degrees, because that's our angle, equals opposite over adjacent. So x over 47.3. Oh, excuse me. 47.3. And then to get x by itself, we're just going to multiply 47.3 by both sides. So over here, that'll leave just x, and over here, that'll leave 47.3 times tangent of 53 degrees equals x. So that's going to be the height of our silo. So it's going to be 47.3 times tangent of 53 degrees. And because this is in meters, we're going to put the height in meters. And that's our height for the silo right there. So that's how you use tangent to figure out one of the sides of a triangle. So now let's move on to number 2. Alright, number 2. So, the problem says, your cat is trapped on a tree branch 6.5 meters above the ground. You will find a ladder that is only 6.7 meters long. If you want the ladder's tip on the branch, what angle will the ladder make with the ground? So you have to figure out what angle, so what's number 2? You're going to have to figure out what angle the ladder is going to make with the ground, so it'll get exactly on that tree branch so you can get your cat. So I'm going to draw my visual triangle with the right angle right in there. And it says the branch that your cat is stuck in is 6.5 meters above the ground. So here's the ground. So I'm gonna draw 6.5 meters right there, because that's the branch. This is how high the branch is. And the ladder is gonna go diagonal with the ground. So it's gonna be our hypotenuse. It's gonna be 6.7 meters. And you're trying to find the angle it makes with the ground. So you're trying to find the angle of elevation, which is right here on this triangle. So I'll put my variable x right there. You can also use theta if you want, but I just prefer to use x. It helps me a little better, but you can do whichever you want. So for this one, we're going to use sine, because we have an angle and we have two sides, the opposite and the hypotenuse, which corresponds to the trig function sine. That's why these trig functions were important, like I said in the beginning. So we're going to do sine of x equals opposite 6.5 over adjacent 6.7. Parentheses. And so unlike the first one though, we don't know the angle. So instead of trying to find the approximate in a calculator, we want the exact answer. So we're going to cross out sine right here and make this, put sine in over here and put the inverse of sine. So we're going to make it over the inverse of sine. So x is going to be over by itself, and it's going to be inverse of sine, which is just sine to the negative 1, and then in parentheses still 6.5 over 6.7. And that's your final answer. That's your, because instead of, you don't want approximate answers, that's your exact answer. You do, to get rid of sine on this side, do the inverse of sine on that side. And that'll give you just the inverse of sine of 6.5 over 6.7. And that's your angle of elevation that you need to get the ladder connected with the ground onto the branch. Okay, so let's do number 3 now. Okay, number 3. So it says, Haleakala is a 10,000-foot high dormant volcano on Maui, Hawaii. The peak is a horizontal distance of only 30,000 feet from the ocean. At what angle would you have to look up to see the peak if you were standing on the beach? That's part A. So I'm going to put part A right here. And so we're trying to find the angle of elevation again. We're trying to find what angle you'd have to be if you're standing. So let me draw my visual right here. Here's 10,000 feet. Right here, that's how high it is. And then here's 30,000 feet. And it doesn't mean anything fancy, but it's a nice visual to help you realize what you're trying to find. And so this 30,000 feet from the base to the beach, and because you do that because it says the peak is a horizontal distance, so that's why you put 30,000 there and not on the hypotenuse. And that's how high 10,000 is, how high it is from the ground to the peak. So we're trying to find what angle you'd be able to see the peak from the beach, which is right here. So we put our x right there, trying to find our angle of elevation again. So we do the same thing, except for this time we use tangent because we have opposite and adjacent. So tangent of x equals the opposite over adjacent, so 10,000 over 30,000. Right there. And we're going to do the same thing. We're going to cross out, because we don't know the angle, we're going to cross out that, make it the inverse of tangent over here. And we'll do the same thing, except for this can simplify, so we'll do the inverse of tangent, which is just tan to the negative 1, and then 1/3. So that's right there is the angle. The angle is inverse tangent of 1/3. That's the angle of elevation you want. And for part B, here, let me just erase this. We have more room for part B. We don't need this anymore. For part B, we have the same triangle as before. We have the 10,000 and the 30,000. But instead, this time we're trying to find the straight line distance from the beach, which is right here, to the peak, which is right here. So we're trying to find the hypotenuse. So we put the x right there for the hypotenuse. Instead of using trig functions, we can just use Pythagorean theorem for this. So we can do a squared plus b squared equals c squared, which is the 2 legs squared equals the hypotenuse squared. So we'll do 10,000 squared plus 30,000 squared equals c squared. So that'll give us 10,000 squared is 1 followed by 8 zeros, so 1, 2, 3, 4, 5, 6, 7, 8, plus 9 followed by 8 zeros, so 1, 2, 3, 4, 5, 6, 7, 8 equals c squared. So then that add and give us 1 followed by 9 zeros, so 1, 2, 3, 4, 5, 6, 7, 8, 9 equals c squared. And then to get just c, we'll take the square root of both sides. So c equals, and the square root of this number is 10,000 times the square root of 10. So that's your straight line distance right there. And you don't want to just do you don't want to make that an approximate answer, because approximate isn't good. You want an exact answer just like that. So that's, and it's in feet. So that right there is your height, is your hypotenuse, your height between the straight line distance from the beach to the peak of the mountain. Okay, that was number 3, part B. Now let's move on to number 4. So, number 4, it says, an observer 5.2 kilometers from the launch pad observes a missile ascending. At a particular time, the angle of elevation is 34 degrees. How high is the missile? So, what we gotta do first is draw a visual, just to give us a representation of what we need. This is part A, by the way. Part A. So, draw a visual with the right angle right there. We know he's 5.2 kilometers away from the launch pad, so that'll go right there. And we know the angle of elevation is 34 degrees, so that'll go right there. We want to know how high the missile is, so the x will go right there. That variable, what we need, will go right there. And we're going to use the trig function of tangent, because we have the angle, opposite, and adjacent, just like last time. So we'll do tangent, and this time we know the angle, so we'll do it a different way. Tangent of 34 degrees equals x over 5.2. And before, just like on number 1, we'll multiply both sides by 5.2. That'll cross that 5.2 there and give us just x. And over here, it'll give us 5.2 times tangent of 34 degrees. And that'll equal x. So that'll be how high the missile is. And we don't want to approximate that, because exact answers are always better, as I said before. Exact answers are always better. 34 degrees. That'll be in kilometers. And that'll be right there, the height of the missile. 5.2 times tangent of 34 degrees. That's the height of the missile. Okay, let's do 4.4b now. Let's do 4b. Okay, 4b. So, it says, how far is the missile from the observer? So, let's draw, like we did last time, 5.2, and we have to know how far the missile is from the observer. So we're gonna have to find this value right here. And since we found the last side, we know it's 5.2 times tangent of 34 degrees. We know that. So we can use Pythagorean theorem like in the last problem, and to find that, since we know that side, we did it in the last problem. So what we can do is, like I said, a squared plus b squared equals c squared. So we can do 5.2 squared plus 5.2 times tangent of 34 degrees, all that squared, equals c squared. So 5.2 squared comes out to be 27.04, and 5.2 times tangent of 34 comes out to be 12.302, and that will end up being equals c squared, and that will end up being 39.3422 equals c squared. And like I said before, we can just take the square root of both sides. And since we don't, and this isn't a perfect square, and we want exact answers, so we're not going to take the square root of that. We're just going to leave it as c equals, or hypotenuse equals, the square root of 39.3422. And we're going to put it in kilometers, because that's how the other ones were in. Square root of 39.3422 kilometers. And that's how you find the direct distance from the observer to the rocket, the straight line distance, just like on number 3. So last problem, number 5. Okay, it says, number 5, it says, a team is building a zip line through the skyline of Atlanta. They have 125 feet of steel cable from the zip line and they have been told the maximum angle of decline can only be 32 degrees. What is the maximum distance the two buildings can be apart? So, what we are going to do here is draw our visual. We have the max the 125 feet of steel cable, so that'll be the zip line right here. The diagonal will be the zip line, the hypotenuse, 125. And we know the angle of decline, the max angle of decline, is 42. And the angle of decline is just the opposite of angle of elevation. So the angle of decline will right there. Here's our right angle right there. And we're trying to find how far the two buildings can be apart. So here's building number 1. And here, right there, is the distance between, here can building number 2 will be. So here's where this is the distance between building number 1 and building number 2 and where they can be. So X will have to be right there. We're trying to find that. So we're trying to find the max amount, since the maximum they can be apart, we'll use the max angle of decline, which is 42 degrees, as I said. So now we can use sine because we have our angle, we have opposite and hypotenuse, just like a couple other ones. So we can use sine of 42 degrees equals x over 125. And then we can cross out, remember, multiply both sides by 125. Cross that out. 125 times sine of 42 degrees equals x. And remember, you don't need to go any further because you don't want approximate answers. So we can just go 125 times sine of 42 degrees. And that will be in feet because the other one's in feet. And that is the max distance between the two buildings can be when you're using the max angle of decline, which is 42 degrees, as they said in the problem. Okay. So, those are all the 5 problems that I have for you today. I hope you learned a lot about right triangle trigonometry. And remember, the most important thing is that you know those trig functions, because you can solve almost anything with those trig functions. And anytime it isn't, it's either Pythagorean theorem or something else. So if you know the trig functions and you know how to do Pythagorean theorem, you can solve almost any right triangle trigonometry problem that you need. Okay. Thank you and have a good day.